Hey everyone, my name is Dave Sexton. This is my 8th video in my series of videos on reactive programming. In this video, we're going to go into the service layer. I think we're going to start building that out based on the spec. I don't know that we're actually going to go into socket programming just yet. I'm thinking more along the lines of checking our interfaces, our contracts, and making sure that they actually work the way we would expect them to from the point of view of the service. And of course, we'll start implementing some queries in there if we can, and maybe build a generator or something. I don't know how far I'll get in this video, but that's the plan anyway. But before I start that, I just wanted to speak about a couple things real quickly. So the first is that I wanted to thank you guys for some feedback that I asked for on Twitter, and Lee Campbell specifically answered very directly, so thank you, Lee. I appreciate that. Looking at the analytics on YouTube for the series, I'm noticing that the average time people watch the videos for is under 15 minutes. Depending on which video it is, it's somewhere between 8 minutes and 15 minutes on average. So clearly that tells me that people are watching it in the way that you had described for yourself. That surprises me, to be honest, because, for example, Bartosz Milewski's video series on category theory, which I highly recommend, by the way, once I started watching it, I binge watched it. I watched it for like 4 hours at a time. So the 15-minute thing doesn't really make sense to me. I'm not sure how much you could learn at all in 15 minutes. It seems like, unless you have really concentrated information. But that's not really the point of the series, so I don't think I could do that. I don't think I could. The amount of time it takes me to just record an hour, and the prep time to set up and the editing afterwards, which takes at least an hour to watch the video back again, but usually about 2 hours or so, and then uploading it to YouTube and all that. The whole process takes a few hours. I'm getting more benefit doing an hour worth of video than if I were to do like 15-minute bits and pieces, plus having to plan it out, because if you're doing such small pieces, I think you really do have to plan ahead so that you have relevant information in each piece. But I don't plan on doing that because it's just a lot more effort for me, that more time out of my weekend to do it. But I respect the problem. I respect everyone's viewing patterns sort of points to that. So I think what I'm going to try to do, and everybody, you could tell me if this is not the right approach. What I'm going to try to do is I'm just going to continue recording the hour series, but then during editing, I'm going to look for pieces that I think are important and relevant, perhaps 15-minute segments if I could find them, things that have some concentrated information in them, or really good relevant examples. Once we start doing a lot more RX programming specifically, like querying, I think there will be a lot of examples where there are operators or patterns that you want to teach to people. So those would be, I think, good places to pull them out and label them for what they are and keep them as separate videos. So almost like a highlights segment or something. So I'm thinking of doing that instead. So that way, if you're not interested or don't have the time to watch a full hour-long video, and you don't like having to watch bits and pieces of it because there's a lot of sort of boring parts and silence because I'm building a real app in real time, then hopefully these highlight pieces would be more like your go-to place, and you'll get the relevant information that you'd look for, but without all the clutter around it that you don't really care about too much. Of course, that's not going to be 100% perfect because, like I said, I'm not planning ahead anyway. So it's really just going to be in post-processing when I decide that this segment of video is actually worth watching as a standalone video. And if I could find pieces like that, I'll publish those to YouTube as well separately. So I'm still thinking about how I'm going to do that. So it might take a little longer for me to figure out how to get this next video out, because I'm going to try to set that up, but we'll see how that goes. And if you have a better idea, I'm open to that, of course. I just want to point out originally my inspiration for the series was the Handmade Hero series. If you're not familiar with that, I highly recommend checking it out. It's on YouTube. I apologize, I don't remember the name of the developer doing it, but the series is similar to similar to nothing I've seen before, actually. What I'm doing is similar to that series in the sense that you're seeing the whole application built, and I'm explaining it as I go. The Handmade Hero series, though, goes into much greater depth. It's video game programming in C. So every line of code is described. There's a couple of separate videos on like mathematics and things like that. Obviously, this is beyond what I'm planning on doing for this series. I'm not going to have a separate branch of category theory and segments of category theory or anything like that. So my goal instead is to really be pragmatic here. Build something that's production quality, show you how you could do that from the beginning to the end, have as much content geared toward reactive programming that I can, but also show everything else, all the necessary components that you'd have to deal with, all the necessary problems you'd have to solve around your reactive program just to get a production quality program in the first place. I want to show all of that, and I want to do that in a way that's actually going to come to an end at some point, right? Like I don't want to be doing this for 6 years. I want to actually get to a point where I could say, okay, the app is now done and the series is done and I accomplished my goal. And that might take several months, but I'm not looking to explain necessarily every single line of code. There's some prerequisite knowledge I would expect for some people coming into the video. It's not for novice programmers per se. It's really designed for people, I think, that have some understanding of programming, at least imperative style or object-oriented programming. But anyway, I don't want to get into that. I think I wrote up some details about that in the README file in the source code, but you could take a look at that if you're interested. The other thing I want to mention is that I don't see a lot of people actually watching the video series, which is fine. I mean, for me, I'm doing this because it's a learning experience for me. Partially, I'm doing it because it's a learning experience for me. Being able to explain what you're doing, while you're typing and while you're actually solving problems is fairly new to me. This would be, I mean, I'm kind of just throwing myself in the lion's den, so to speak, by recording myself doing this for the first time. So I'm hoping you're just bearing with me while I'm trying to get better at this. Hopefully I'm succeeding. Obviously, the more people watching it, the better it is, I think, if in fact it's actually useful to them. I wouldn't want people watching it if it's not the right approach to teaching people how to do reactive programming. But insofar that it's actually a good method for it, if this little experiment actually proves to be useful, then I'd want more people to watch it. So I don't know how to increase the number of people watching the video series, but obviously I would ask anybody who's watching it and actually enjoys watching it to let other people know, let other programmers know that it's here, because the more people watching it, really just statistically, then increases the chances the more feedback I'll get, and the more feedback I'll get, the better it is for everyone and for me, because it will continue to motivate me to do the series. Like I said, right now I don't quite need that motivation. If there was even just one person watching it, I'd probably continue doing it. So anyway, this is more just like an appeal to help me get some more people watching the video series, if you think it's actually worthy of it. If you don't, then by all means don't tell anyone about it. I would respect that decision as well. I see it as an experiment, so hopefully it's going well. All right, so I think that's enough of an intro. Let's take a look now at the service spec. So I don't think we've actually reviewed this yet. So this is let's go to the top here. Cross-cutting concerns we're not doing yet. We may have so I think we're going to start with an in-proc service anyway. We don't have a project for that, right? Yeah. So we don't have a service project yet. So maybe we'll just hold off on that for the moment. Oh, well, we could, what I'll probably do then, just create a service project where I could put the service code, even though the assembly will just be loaded into is referenced by the desktop app directly, and we could just have an in-proc service. That way we don't have to deal with socket programming or network programming in general. We could just deal with the business rules, right? And then it should be very easy based on the design that we're using, reactive, and we'll be using probably tasks in some cases on the edges, I'm just assuming. Maybe not, but we'll see. I tend to do that, so that's why I'm just assuming I will be using task and async methods, but maybe not. Maybe if everything just is easily representable and appropriately representable as observables, then we'll probably just use observables. But once we have that design, either way, it should make it very easy for us to then just move it to an actual service. We just have to build the adapters that wrap, the network layer, like sockets, for example. So similar to how we did it for the presentation layer. WPF doesn't really support our reactive approach, so we built some wrappers, we built some adapters, and then now we could consume them in a way that is of the design, our intention, reactive design. And then we'll be doing something similar to that on the network side of it as well. But for now, I think, we won't be dealing with the network stuff. So let's just add a new project. So we need to have two projects here, right? We're going to have one project is going to be the actual service, the executable, right? Which I think I'll probably end up just doing it as a ASP.NET app. I don't see why not. And then I'll just, have my own socket code or something like that. I don't want to rely on any third-party libraries. We're going to be building everything from scratch anyway. So it doesn't quite matter how we host it. I mean, I can even host it as a background service in Windows if I really wanted to. Maybe something with .NET Core might be nice, actually. I don't know that I haven't built a .NET Core web application yet, so that might be kind of a fun thing to do. I'll record myself trying to figure it out. But that's one side of it. The other side is obviously the library, which we don't have to separate these, but I'm going to separate it and have the library do most of the heavy lifting there, because then we could just load it in proc into our WPF app, and we don't have to actually have a service component. So because of that, we need two projects. So one will be chat service, and the other is really, so one's going to be like the executable, one's going to be the logic. If we're going to, I guess I almost want to make that decision now, because then, okay, so how about this? Chat service, although I could just put, technically I probably could just get away with putting the service implementation in the business layer project, because it's only going to be a few queries, right? Nah, I'm going to create a separate library for this, because I just know, from experience, this is the kind of thing that will grow, and having them grow separately, I think, makes more sense. So you have the business layer, then you have the service implementation in this, so the service layer exists in like the client tier, but then you have the service tier, which has its own reactive program with its own queries and stuff. Even though there will be some duplication, if you will, we could have a common library that shares any duplicate operators we might need to build ourselves, custom operators, that kind of stuff. I don't think there's going to be anything that complicated in this program, but that's something we could do if we needed it. So yeah, I'm going to keep them separate. I think that's probably a better architecture from day one. So chat service will be our application that, this is just selecting the folder. This will be our application that has all of this service logic, okay? And this can just be a class library. We will target .NET Standard because we may want to use .NET Core to build a web app. And I think that is good enough. Okay, I'm going to delete this class 1. And now we know we're going to need a reference to system reactive, so we might as well just go ahead and add that right now. So this is reactive extensions for .NET. Am I using the pre-release for the other ones? I don't even remember. Let's do it this way. So for the entire solution, I am using the pre-release one. That's cool. Okay, so let's install that. Good. And you know what? Might as well add value tuple to that as well, because there's a chance we'll be using that. I should say a good chance we'll be using that. Okay, so now we've got our service project. And let's take a look at the spec. Server design. Startup and configuration. And we could read it on the right-hand side here. So first load the server settings, whitelisting of IP addresses, listen for client connections. So right there, we can see that this is a representation. We can represent this requirement as an observable, right? An observable of client. So listen is really a synonym for subscribe, right? You're subscribing to an observable that will push clients to you. So there's our first observable, I would say. And then this describes how connections are received. So we'll get into that. Disconnecting when a client disconnects. So that when implies time. There's clearly something related to, if there's something related to time, then there's concurrency. And if we want a concurrent programming model, we could look towards reactive extensions. We could also look at task-based asynchrony. So that's a possibility as well. It depends on the cardinality. Do we care about one notification and one notification only? Or do we care about potentially zero to infinity? If it's a latter, then a reactive approach would be better, using an observable because it's a stream. Whereas using a cardinality of a single notification, we would use task because that's what task represents. It's a better model for that kind of requirement. And then multicasting, when a message is received, another when, right? Then we do the multicast operation. So, okay, pretty simple concept for part 1 of the series. I think we could implement all this stuff fairly easily. Here's the little, negotiation dance at the time where the client connects if we want to authenticate. We already handled this on the client side a little bit, right? So that's probably, of everything in here, that's the largest part. So, yeah. So why don't we start by, unfortunately, we have, in this object-oriented first world that we live in here in C# and most other languages that, like Java and JavaScript, for example, you're going to be in a world where you're going to have to create some kind of type to contain your functions, unless, I guess in JavaScript your types are your functions, but that's very weird, and I'm not going to go there. But for you Java folks out there and C# folks, obviously, if we're going to do a reactive program, we still need a type to hold that program. So we already did that once before, I believe, right? Oops, that would have been in here. Oh, no, that would have been the business layer, yeah. In the business layer, we have the reactive program. So why don't we do the same thing here? We'll just call it reactive program. This is really where all of our logic is going to go, right? It's like the core of our service. And our reactive program, I'm going to see if I could share again. Is this going to be annoying again? Maybe I'll just share vertically like this. Let's stick with this for now and see how this works out. Okay, so in our reactive program, we are going to listen for clients. So remember, just like we did in the presentation layer first and the business layer, we're designing using a reactive-first approach, which means thinking in terms of input and output. Right? So we're defining the contracts for our API first in terms of inputs and outputs. So we already know that listen for client connections is an observable of client, which is input to our service program. So we can represent that by saying, let me format this. There we go. Observable, I should say public, right? It's a public observable of, now we need some representation of a client. So this is where object-oriented programming becomes useful, right? We could create a custom data type to hold the information that represents a client state, right? So we'll just write client now, and I'll generate that later. And we can call this clients, plural, because there might be more than one that connects, right? And here we could say private get and a public setter. This is our representation of input, right? So publicly, you could set the client observable, but you can't subscribe to it. Internally, we could subscribe to it. This is how we're going to represent input. Actually, in an earlier video, I made the mistake of getting confused trying to use a new C# feature where I could do, lambdas or something. And I forgot we could just use a private get. That really does represent my intention here as being input only. It's likely, like we have already done in the business layer, that we'll probably end up having an input class or an output class and separating the stuff. But I see no reason to do that right away. We'll do that when we need it. For now, we'll just put all the inputs and outputs in this program directly as public properties. And to set up the program, you would just create an instance of the program, assign all your inputs, subscribe to all your outputs, and then call some start method, right, which starts the server. So obviously we'll need a start method. It might end up being called connect. As a matter of fact, we could technically return an iDisposable, which will allow you to stop the service. It's nice having the iDisposable here, so you don't have to have a separate method called stop. You have an interface, an instance of an object that you could just pass around now and store somewhere else. You don't even need a reference to the reactive program anymore at that point, right? You could just hold a reference to the disposable and dispose of it when you want to stop the service. You want to start a new service, you want to restart it, dispose of the disposable, then create a new reactive program, initialize everything, and call start again. For example, that's one way you could do it. So we don't need a stop method here. We'll have to implement this at some point. For now, let's just return null. Actually, I could do it like this. Okay, so that's pretty good. And this will tell us what to do when a client is received. So, well, technically we're going to have to do that in the start method, right? So I might as well just get ready for that. I'm not sure exactly what the shape of the client has to be yet, so let's not make any guesses here. We'll see what we need as we read through the spec, right? So we'll generate that type once we realize we need it. So for now, we'll just look at what happens when a client connects. So when a client connection is received, we check if the client's IP address is not in the whitelist. So that's something we could implement later, but let's just see what this would look like in a query form. So we would say from client in clients, where, right? We're going to say, well, let's see what we do if it's not in the whitelist. We terminate the connection immediately without any response, which could just mean we actually don't do anything with the client. Maybe the client will be disposable or something, and we could just cause a side effect, and that will terminate the connection. If the client, say, wraps some sort of socket connection, then disposing of it kills the connection. Or maybe it's the opposite. Maybe you have to actually now activate the client in some way or do something with the client in order for it to actually be used. And if you don't, then it's terminated automatically. That's another way of doing it. I think the latter way might be a little bit more confusing. So I think an explicit disposal makes more sense to me. So let's just assume client is iDisposable also. And that way we can just dispose of it in this case where the client's IP address is not in the whitelist. And that's how we'll terminate a connection. So when the client is in the clients, so from client and clients, we could say where not is in whitelist client, select client. And this would be our, let's say, unlisted clients or something like that. And we want to cause a side effect here, which is to terminate it immediately. So we could just subscribe to it. Oh, I think we just need a using statement. I'm not getting IntelliSense here. There we go. Still not getting IntelliSense, I guess because this is not implemented. So let's just put a little stub here for this. And now we get IntelliSense. So we're going to subscribe to the unlisted clients. And what are we going to do with the client? We're just going to call dispose on it. So we'll have to create a implementation of iDisposable in the client. Now, if the client is listed, we'll have to do something different perhaps, right? So we could say for listed clients, client in clients, where is in whitelist. Now, you may already notice that there's duplication here. We hate duplication, right? We do not want to have two business rules that are essentially doing the same thing. In this case, they're doing opposite things, but the side effects are going to happen twice, right? Once in each case. What we'd want to do here instead is just check is in whitelist once, and then split the query off from there. So if you recall from the first, or was it second video or something, we solved this problem by using the publish operator. So I think that's a good approach. We'll just do that again here. Essentially what we want to do then is we want to say not where is in whitelist, but we could put it here. We could say, we could just call this clients. And it's not where it's in the whitelist, but we want to project whether it's in the whitelist or not. Oops, I messed up my clipboard. Is in whitelist client. Now, if it is in a whitelist, we're just going to get a Boolean back. But we don't want just a Boolean, right? We want it tupled with the client. So we could just use a value tuple for this now. We could say whitelisted equals, is it equals? No, colon. And client is client. Is not defined or imported. I thought I did. Did I not add a NuGet package for that? Huh. All right. It's going to be interesting when I go to edit it and see exactly what happened there, but I could have sworn I added a value tuple. I said I'm going to add value tuple because we're probably going to want to use it, right? Oh, there it is. Yeah, but look, it's not even in this one. All right, I don't know what happened there. Well, let's do an update first. And then, what is going on here? There we go. Yeah, it didn't add it. I wonder if there was some kind of error or something and I didn't notice it. It says finished. Value tuple, it says it's in there now. Okay, I don't know what happened. Sorry about that. Back to the code. And I think I could actually make the code a little bit higher. Less spec, more code, right? Maybe half and half? Let's try that. Okay, so now we've got a value tuple here, which is nice. So if we mouse over the var, we could see T is a tuple of Boolean with the name whitelisted and client with the name client. Type client, property name client. Okay, so that's perfect. So now, instead of capital C clients, we could use lowercase c clients, the local here, and we could say where client.is, or just whitelisted, I didn't put an is in it. Then we could say select client.client, although maybe state or something would be a better way of putting it, or C. It's really a pair. Yeah, whatever. So we'll say pair here, change this to lowercase c, and this one is where pair, oh, the other one was a not, right? So unlisted clients are where not pair.whitelisted, and listed clients are where pair.whitelisted. Select pair.client. Now, I forgot, the important thing here is we want to share this side effect, so we have to call publish here. Now this is going to give us a connectable observable. Because we're in the start method and we need to return a disposable, we could just technically return that as the disposable. Although we could just, for the sake of completion here, have all disposables, all subscriptions that we make, composited together into a single type that implements iDisposable that when disposed, disposes of all of its contained disposables. Of course, that's a pretty common pattern. RX provides a type for us to do that called Composite Disposable, if you spell it right. And it is in the System Reactive Disposables namespace. I'd be surprised if types like this don't exist in other implementations of RX for other languages or platforms. It's possible that they don't, but I would hope they do. I find these to be really useful. if there's some kind of disposable pattern or cancellation pattern that's reified in a type, then having the set of disposable types that RX provides for .NET, I think is really useful. It would be useful in any language I could think of. So anyway, composite disposable. Let's take a look at this. Oh, actually, in this case, we're going to want to use a stable composite disposable. What this means is that it's going to be built as an immutable type, and then you can't use the constructor. There's actually a static factory method for it called create. This is an immutable type. This is a little bit more efficient than using a composite disposable, which is mutable. Composite disposable, you can think of it as like the combination of a list and an iDisposable, right? You could add disposables later, and when you remove a disposable, it's automatically disposed upon being removed, and so on. Stable is immutable. As a matter of fact, we could prove that. Let's just take a look at the source here. So we can see a Boolean property, whether it's disposed or not, and the create functions, which we're going to use one, and then a way to dispose all of its contents, but that's it. Right? There's no add method. It doesn't implement iList or anything like that. So we'll go ahead and create this, and it takes a parameters array of disposables. Perfect. So now we could just call connect here. We want to call connect last, though, right? We could even call the subscribe before we call connect. So in the order in which this is processed imperatively, it will cause all the side effects, our subscription side effects. In this case, because we're subscribing to unlisted clients, which is a query that's built in terms of a published observable, subscribing to it will not have any side effects. It's therefore a hot observable. The only way to cause side effects is to call connect on the underlying observable clients, which is exactly what we do here. I don't like scrolling up and down this much. I feel like it's detracting from the point here. All right, so clients, we call connect, and then it causes any subscription side effects that may, on observables that may have, or observers rather, that may have already been subscribed. So in this case, there will be two observables that we're going to subscribe to, unlisted and listed, and maybe more. We'll see. And we'll subscribe to all of them without causing any side effects because they're all hot observables. And when we connect, then that will call subscribe on the client's input here. So we will only ever receive one subscription. Right? So publish is very important. And what it's doing is it's converting, if clients may or may not be a cold observable, but it's converting the temperature. If it's cold, it's converting it into a hot observable. So we can subscribe multiple times and not cause any subscription side effects until we call connect. We defer the side effects until we call connect. Right? So a very important operator. Now, we have listed clients. We could do something with that as well. Let's take a look at the server design one more time here. I just want to make sure that I'm not stepping too far off course here. So load the server settings. If any whitelisted IP addresses are specified, oh, this is the startup. Listen for client connections. When a connection is received, which is just a client notification coming into this observable, then if the client's IP address is not in the whitelist, that's the unlisted client's query. So if, from pair and clients, we're not pair whitelisted, select pair.client. I don't like pair. Just call it C. Right? Then terminate the connection immediately. So now you can see how we've actually implemented this business rule, right? Here's the query for the rule. Perhaps the side effect being sort of part of the rule might make more sense together. So I was planning on just listing all the side effects down here as we subscribe to them. But sometimes it's nicer to have them right where the query is defined, for them. Or technically what we could do is maybe we'll just have everything in line here. Why not? It's not terrible. Having names like listed clients and unlisted clients could be potentially useful, but isn't absolutely necessary, especially if we're only going to have a handful of queries. So why don't we just continue with that? Sorry, my clipboard's misbehaving again. There we go. And we'll do something in subscribe. We're probably not even done with this query, actually. But so this is a little hard to read. Maybe we'll just put a little space in there. So now back to the top here, start. We create our published clients that includes the whitelisted check. And then here's where all the business rules are going to be implemented. Right? Yeah, I think I prefer it this way. So you can see the subscription side effects next to the observable to which we're subscribing, and that covers the rule entirely. So it does read a lot more like the spec in this case, right? So line 1 is when a client connection is received. That's this from C and clients. If the client's IP address is not in the whitelist, that's where not C whitelisted. Again, we don't really care about how that happens. The how could be somewhere else. The implementation could be somewhere else. This is just about implementing the business rule. The business rule doesn't say how to check whether it's not on the whitelist. It just says if it's not on the whitelist. Well, this reads very much like the spec. It just says if it's not on the whitelist. Then we terminate the connection immediately without any response, and that's dispose. So it's not exactly like the spec. We can call it terminate without response. You know, if you want to be really, really accurate. But dispose is a very common pattern. So at least in the C# world or .NET world, you would know what's happening, I think, when you saw this. So this would make sense. It would be correlated intuitively. Okay, cool. So now, what else? Then if authentication is enabled, we do some stuff. Otherwise, add the client to the subscription list, which I think also happens even if authentication is enabled and the golden path, right? It gets through everything. Then we're still going to add the client to the subscription list. So that's going to happen no matter what. It appears to be the primary side effect of the query, right? So if it's whitelisted and yada, 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 stuff related to authentication, then we take the client and add it to the subscription list. So now we have to consider what a subscription list means. Well, actually, maybe let's just go in order then. Let's do the authentication first. Yeah, let's do that first. But at some point, we're going to have to deal with this as well. And this is maybe a little trickier, so I'm not sure we'll actually get to it in this video. I don't want to jump to it. That's why I'm liking the path I'm taking here, just sticking with simple RX queries that read like the spec. But when we get to this, we might end up having to do something a little bit orthogonal. So I don't want to jump there just yet. But if we look at the authentication as enabled requirement, then we could see that this is like a branch, right? If authentication is enabled, then do something else. So for that reason, we could think of it as, so there's two ways to look at this, right? We could think of this as two separate queries where this if authentication is enabled branch is like saying, okay, when a client connection is received and it's in the whitelist, then perform this operation with this subscription side effect. And then a separate observable that says when a client's connection is received and it's whitelisted, then just perform this subscription side effect directly. Then there will be some duplication, though, in that case, of the subscription side effect, right? We'd have to have two places where we call subscribe and do the same thing. That might not be so bad if we're just calling a method or doing something very simple, but it's still duplication, right? And obviously, in the worst case is you're doing something that requires a lot of state, and it's not as simple as just calling a separate method. You have to prepare something or type first or something like that. Then duplicating it would be... I'm not saying we have to do that, by the way. I'm just saying, in theory, when something like that happens, the duplication is really harmful to your code, right? It's not as clean and as maintainable as you'd like it, probably. So the question is there another way to do this where if you notice a branch here, is there a way we could take this initial observable and then branch it to do one thing if necessary and then sort of join them back again to perform the final subscription side effect? And the answer, of course, is yes. So how do you do that, though? How do you do this separation? Well, if we think of it as, if we go take a step back, right? Because I want you to think reactively here. If we take a step back and we think of this as an observable of whitelisted clients, then we could think of it as two separate observables where one of them does some additional processing, right? Maybe some side effects, but everything's asynchronous, right? We're awaiting responses and so on. So it's still asynchronous. It's still an iObservable that produces some output, which is essentially the same as the output if we didn't do this at all. And then a subscription side effect happens. Now, because we're representing this as an iObservable, I'm sorry, I'm scrolling up and down a lot again. Because we're representing this as an iObservable, there's something wrong with every time I try to move this. See, look, it's not taking. I'm holding the mouse down, and it just won't let me move this. There we go. It has something to do with, I think, this editor. I feel like, well, maybe I'm wrong, but I think it has. You see, look, it's not letting me move it up again. Yeah. I don't know. It's been like this, not just for this video, but for several videos now. So sorry, I'm venting a little bit about it, but it's been very annoying. Every time I try to do that, I don't know what the problem is. Maybe I'll try to get down to the bottom of it outside of the video series. But anyway, I apologize for that distraction there. So back to what I was saying. The point is that if we have an eye observable here as input, and so let's call this observable A. Then we have another observable which just adds some stuff to the original one. We'll call that B. Then we could just pretend, because it doesn't really matter in this case, we could pretend that they have completely different sources. So it doesn't matter if A and B share the same source. Let's imagine for a moment that they're completely different observables. You have A and you have B, and they don't share anything in common at all. They're completely different, except you want to cause subscriptive side effects in both of them when either of them produce a value. Okay? So you have two completely separate observables, but the same side effect when you subscribe to each. And you don't want to have to call subscribe twice on both of them, or once on each one, I should say. So twice in total. Instead, you want to call subscribe once. Well, then how do you combine the two observables in such a way that you could call subscribe only once? I'm going to try to move this back up again. It worked. All right, good. So the answer is a very simple operator, as you might imagine. That's the beauty of RX, right? A lot of these things that might seem complicated at first end up being a single operator that's very easy to use once you learn how to use it, perhaps. But the solution to this problem is an operator called merge, right? So we have one observable, A, and another observable, B. The merge operator will allow us to create a new observable that will generate notifications whenever either of the input observables notify. Okay, so if A pushes a client, then a client will go to the output. If B pushes a client, then a client will go to the output. And the output observable is just another observable. We could just subscribe to it directly, but we could also write a query on top of that if we wanted to. So how would we represent that here? Well, we need two observables, right? So why don't we grab this one here, which is essentially the, let's say we'll have two of them, right? Authenticated are the clients that are authenticated. And, oh, actually, I just realized I might not be doing this. I don't really have to do it this way. Yeah, sorry about that. I don't know why. It just dawned on me that this if block is not based on the data coming into the observable. I was all excited that we were going to get to use a merge. All right, we'll just have to hold off on that. You know what? Maybe I'll continue just to show you what I would have done. No, I don't want to. That's that's too bad, actually. I don't want to do that. I think that would just be a distraction, maybe. No, I'm sorry. I'm sorry if this was going to be something that was useful and turned out that I just misread the spec, my own spec. I was too excited to do something more interesting than what we've been doing. So, you know what? I am going to finish it anyway. The thought this will maybe go into the highlight, even though it doesn't actually implement the spec. So I'm going to end up undoing this code and then implementing it the way I really should. So this is what I'm thinking. Let me explain myself here. In case you didn't notice, you probably noticed it before me and thought, "What the hell is he doing?" But if authentication is enabled, is a flag that's like external to this query, right? It's just, what is the state of the application? Are we authenticating or are we not? It has nothing to do with the data that's coming into the observable. So for that reason, it means that we're only choosing one query or the other and then subscribing to it. So we don't have to do anything really tricky there. We just have to say, check some Boolean from some state somewhere, some configuration property or something. If authentication is enabled, then this is the query we're going to generate on top of the whitelisted query. Otherwise, we're just not going to add this query to it, and we're just going to subscribe directly. So this is a nice thing to implement anyway. I'll do that now just because that's useful. Well, I'll do it in a moment. But I just want to finish the thought for the merge because I got really close to the end of it, and I think it's a nice thing to know about if you're not familiar with it. So sorry for jumping around so much here. This is what happens when you don't plan, right? So on the left side of our well, so let's look at it as we have two separate observables, right? We have this authenticated observable and this unauthenticated observable. So this is what made me notice that I obviously misunderstood the spec, because this doesn't quite make sense, right? Why would we ever allow unauthenticated observable notifications? Well, we would if we don't need authentication to be enabled. But okay, so anyway, if we ignore the spec for a moment here, the general idea is that we have two separate observables and we want to merge them in some way. So what we would do here is we could start by defining the base query that they're going to be glued to. In this case, the expectation was that they'd have the same source. Both queries would be based on top of the same subquery, if you will, or source query, I guess would be a better way to describe it. But that's not necessarily required. Obviously, you could have two completely separate observables. As long as they have the same data type, you could merge them using the merge operator. So in our case, we wanted to, in my misunderstanding, base them off the same query. Now, because we want to base them off the same query, it means we have to do a publish again, right? So it would have been something like this. It would have been, let's say, whitelisted equals this, although we'd publish it. Oh, well, okay, so this is actually a little bit better. We don't have to republish the where clause for whitelisting, right? We could just repeat that if we wanted to. That's probably not too bad if we just repeated that. The publish is costly. You don't want to have a lot of publishes everywhere. We want to avoid them if we can, as a matter of fact. You don't want to just throw them in everywhere. So in our case, I think it would be cheaper to just have a separate where check here in both queries. So let's do it that way. So we're going to have a where whitelisted in both cases. And then for the authenticated one, you might say something like from, authenticated or auth or whatever in do auth async, something like that. And you pass in the client. And then, so this would actually compile into a select many query with a where clause attached to the input. Two froms, consecutive froms compile into a select many query. So we could just use the select many operator directly in the fluent method syntax, but I like this syntax better. I think it reads nice. It also keeps our variables in scope all the way to the bottom of the query. We don't have to create our own types or tuples or anything like that. The compiler just does that for us, so it's a nice little syntax that makes our lives a little easier. And I find it easier to read, but perhaps that's a little subjective. So anyway, so we have our select many, which is sequential composition. First do this line. It's almost like imperative style code, right? First read this line, and when a client comes in, then do this line, which is, do auth async. Then when auth comes in, now we have auth in scope and C in scope, the client pair in scope. And we could do a projection. We could continue the query with another from if we wanted sequentially, whatever we want to do. So in our case here, we'd probably say, let's just return the client, because once auth is completed, we could throw away any data or state that was required in order to perform that operation. We know they're authenticated now, maybe even enhance the client object to capture any state we need or something, and then just project the client. Remember, the data types are going to have to be the same if we want to use the merge operator. So we'll just project the client the way we normally would. In the unauthenticated case, it's just, we don't even have to do this step here. That's the only difference, and just project the client. And now that we have these two observables, we would just simply say, go down here. So what is it? Authenticated and unauthenticated, right? So we would say authenticated.merge with unauthenticated. And then we could just call subscribe directly on that. We don't even need this extra parens. It doesn't like this for some reason, because I'm not getting IntelliSense unmerge, unless Visual Studio is just behaving badly again. So it sees this is an observable of client. It sees this. Oh, it doesn't know what authenticated is. Oh, because of this, right? Sorry, my bad. So we could just represent this as, just for the sake of example here, auth could just return an observable of. Oops. I'm not going to actually execute this code, so it doesn't really matter. So we'll use unit. We've already seen unit before, so I won't explain it again. Just think of it as like a void that actually has, that represents a single placeholder, if you will. So now it should understand what this is. It's an observable of client. Yep, T is client. and now our merge operator works. There we go. So merge has another overload. Actually, merge I think has, so I think there's other overloads in some custom operators I've built, but in the official RX, you can see that there's two overloads. The first one just takes a second client, and the second one allows us to also pass in a scheduler. There's another merge operator though, called observable.merge. Oh, we haven't even talked about schedulers yet, but I don't think this is an appropriate time, so we'll defer that talk to the future as well. But schedulers are a pretty important thing in RX, so we'll get to them eventually. But you'll see if you just call observable.merge directly, there's a whole bunch of overloads, 11 actually. And they do a bunch of things that I'm not going to get into, but you'll see that if you go through these, there's a lot of cool stuff you could do. This is, in particular, this overload with max concurrent is pretty useful. So if you're interested, you can take a look at that in your own time. I don't know that we'll ever be getting to those overloads in this application, but it just gives you an idea of the breadth of possibilities in operators like merge. And many operators throughout RX have many overloads that do various things. So, very subtle differences between each overload. So it's worth, if I teach you an operator, it's worth looking at the other overloads yourself and seeing what else is available in your own time. Okay, so again, like I promised, we're going to have to delete this because it doesn't really implement the spec, but hopefully this was a nice little explanation of the merge operator, and it's something you understand now. If not, of course, I'd be happy to take questions, by the way, so if anything's unclear, feel free to ask questions and I'll try to address them in subsequent videos. Okay, so now what do we want to do? We want to delete this because it's not useful to us, but what do we really want to do? We want to actually implement this whitelisted query as just a single query that's either going to perform authentication or not. So what we could do is we could start out by saying, let's grab this one here. Actually, let's just rename this to whitelisted. So here's our whitelisted observables. Oh, observable, excuse me, it's singular. So this is our whitelisted observable, which may have more than one client pushed through it. And every client that we get out of this thing, we know it's whitelisted because we checked in the where clause, which will filter out clients that aren't whitelisted. And now that we have this, we could decide conditionally if we want to attach an authentication query to it or not. So it would be like if, authentication enabled. Now, because this is some sort of service configuration, startup parameter thing, it's also just input into the reactive program. Although I don't see any reason why we couldn't just keep the getter public for something like this as well. But the default will be false, and then anybody creating the reactive program could decide to set it to true before calling start, right? So now if authentication is enabled, we can enhance this whitelisted query, which I'll do in a moment. Before I do that, I just want to point out something very important here. The fact that we could do this. Well, actually, you know what? I'll point this out after. Maybe it'll be easier to see once the query is actually defined. So let's think about this for a moment. What do we do if authentication is enabled? Well, we have the spec to go to. So send a password request to message to the client. So let's start out by saying var q equals from client in whitelisted, right? Select client. So now we have a query of all of our whitelisted clients. We want to send a password request message to the client. Now, if sending fails, then terminate the connection immediately. Essentially, that means that if there's an error, we want to terminate the client. If there's an error sending, then we want to terminate the client. So that's actually a good one to deal with. We'll have to probably use the catch operator for that. So before we get to that, this concept of sending a password request message to the client, we know that the client is probably over a network, right? I mean, in our initial implementation of this, it's not, but it will be at some point. And network communication is inherently concurrent, right? Or I should say rather asynchronous, right? Well, technically, all right, let's just say asynchronous. So because it's asynchronous, it means that we want to type that we want a model here that represents an asynchronous message pass. Right? We're going to pass a message asynchronously to this client somewhere else in the world, and then we want to not block the current thread, but be notified later when we get a response, right? So there are two ways to implement that, two modern ways in C# anyway. One being an observable, right? We already know that an observable is a model for concurrency. So we could represent the invocation to send a password as an observable that only contains a single value, which is either, well, it may or may not contain a single value, right? It's either it contains a single notification, which represents success, or no notification, which could just be an uncompleted call that also represents success. Alternatively, it could call on error, which is the failure case. So that works, but it's not ideal for a couple reasons, but I won't get into the details. Just I want to point out the second alternative, which is to use a promise. In C# it's called a task, right? Excuse me, I think it's typically referred to as a future, actually, not a promise. I think a task completion source is generally referred to as a promise. But anyway, a task is a future, and it represents the call, the asynchronous call to, in our case, it would represent the asynchronous call to send the password request message to the client, and it contains three possible responses, right? Either it was canceled, or it was successful and may or may not have some result along with it, some data, or it was a failure. So that also models it, just like observable does. And like I mentioned before, the difference is really just in the cardinality. An observable could have multiple notifications. It could push multiple notifications to an observer, whereas a task could only have one. If we only want one notification, then using observable doesn't make sense, at least in C#, because we have futures and we have a nice way of consuming futures. As a matter of fact, we have a really nice way of consuming futures. Even though we're in the world of observables right now, we could actually still interoperate with a task as if it was an observable. We could just continue our query as if the function was returning, that we're about to write, was returning an observable, when in fact it's actually just going to return a task. But there's another reason why we would use a task from the point of view of the implementation itself, but I don't think we're going to implement that right now. At some point we will. So the way the query would look would be another from clause. Remember, two consecutive from clauses represent a select many. It's like sequential composition. We're composing one observable with another, with another. We could just keep adding from clauses, and they'll execute top down, similar to imperative style code. So this call will actually, this query, as it will be, would just compile directly into a select many operator. So anyway, so when the client arrives from client and whitelisted, and for each client, we'll send the password request to the client asynchronously and await the response. The password response is obviously going to contain the password. So we could just say from password in, and now we need an API to call, which we know, because I already described, is going to return a task of string or whatever. But where do we put the API? So we don't want to spend too much time on that. I would say that perhaps, we're in the object-oriented world as well. Why not have that on the client type itself? We'll say client.send, let's say send password request async. Async, just a common pattern for naming methods that return a task. So this thing will actually return a task of string, which will be our password. And Rx has an overload in select many, which allows us, for the second observable that we're composing with the first, to actually, it's a function rather, we can have one that actually returns a task rather than an observable, and it will just deal with it as if it was an observable that only had a single value. Now, there's one gotcha here that's fairly important to point out, although in our case it's not going to be it's not going to be important. In most cases it's actually not, but when it's important, it's really important. And that is to say, when you're interoperating between observables and tasks in Rx, you can see how elegant it is, and this is a little misleading in some cases, with select many especially, I think. So it's really nice that you could do this, but keep in mind that the threading context that you're in will likely change. It's practically guaranteed. And the reason for that is because of the way tasks are implemented, the way the task APIs are implemented, and the way Rx is using them, actually. So that doesn't affect us here because RX is a free threaded API to begin with. It doesn't care. We're not introducing any concurrency here. We're not even asking to introduce concurrency here in our async call. We would be fine if this returns synchronously and if RX allowed it to execute synchronously. RX doesn't care. The select many operator doesn't care. The task implementation itself will probably introduce concurrency here, though, and that's it will probably call back on a separate thread, a pooled thread, actually. And that's perhaps a little surprising if you're running this query or running this query on a UI thread, and you know that you're going to be on the UI thread up till this point, and this async method captures the sync context and runs on the UI thread. It's likely that you're still going to continue the query on a pooled thread, and that might be surprising, especially in a UI context. But in a context like this, like in a server side, it doesn't really matter to us, right? So we might have one thread that pushes in the client. It's probably an IO completion port coming from a socket or something like that. And then we're going to immediately send another message out over the socket, probably a duplex socket, right? We'll send a message back to the client. And then that's it. The thread of execution that was invoking this, pushing this notification in, we return to that caller and it does whatever it needs to do. At some point in the future, the password is received and then RX will continue, the select many operator will just continue the query. But because we're using a task in this case, we're not actually doing, hypothetically we're using a task, we probably will. The task mechanism will probably marshal the callback onto a pooled thread. So even if our implementation of the async, which again probably doesn't defy your expectation already, but if you're on a UI thread and this async method was implemented so that it runs on the UI thread and captures the sync context, you would still be, this code here in the select would still be executing, its continuation will be executing on a pooled thread, very likely. So it might be surprising in that scenario. But RX is free threaded, so it doesn't matter that the thread that we're getting in the select is a different thread from the thread that we're on when we invoke this client send password request async. So it doesn't matter, right? And the select many operator itself doesn't strictly introduce concurrency, and that's very important. RX operators in almost every circumstance don't introduce concurrency. There are a handful that do, and those are the pretty obvious ones. The ones that really deal with timers in almost every circumstance are the ones that will, by default, introduce concurrency. And they all have overloads for all those operators that take iSchedulers so that you could change that behavior if you wanted to, except for the select many overload, I believe. So that's, again, it's kind of an odd man out there. But that doesn't mean you should avoid using tasks and observables and mixing them like this. I find this to be a really beautiful, elegant way to mix the models. You just need to be aware of that. And it's almost not a problem at all in server-side programming, and in some cases even when you're programming the UI, as long as you're not UI thread-affine, right? If you are, then your expectation might be broken, okay? So that's fairly important to be aware of. There's a way to cure this, though, by calling toObservable and then passing in a scheduler, I believe. But that's, all you're really doing then is just taking this pooled thread notification. You're taking the response, which was actually on the UI thread, and then the task is moving it to a pooled thread, and then you're just moving it back to the UI thread. So it's sort of like this hop for no really good reason, except for the fact that the task library is designed to be more efficient, and that's why it introduces concurrency in each step. But I would argue that, especially in the observable world, the operation you're doing here, in our case, is probably going to be fast enough where it falls under the umbrella of, just being a synchronous continuation would work fine. Anyway, I digress a little bit there, sorry. So hopefully that's clear, but if it's not clear, then there's actually a discussion about this in the GitHub repo for rx.net, I believe. So yeah, you could search for that and check that out if you're interested in more details about this. Okay, so what were we doing here? If the authentication is enabled, right? So now we get the password from the client, and we also have this other problem here, which was, what if sending fails, right? You know what? I'm wondering if I should, because we're gonna have an error here, and I'm not gonna get any IntelliSense. I'm wondering if I should just implement this. So we're in a place now where we're pretty sure we're gonna need this client type. Might as well generate it, and we're pretty sure we're gonna need this function. Where am I generating it? I'm generating it in the chat service. Yeah, I think that's good enough. We could put it in the business layer, but does the client need a type called client? We have user. That's sort of like the other side of client on the client side, right? We could also call this user, or just have this as user. But then see, there's some ambiguity here. This would be representing a socket and have socket-like functions from a service, whereas the business layer is more about the client side types, right? So having the separation, I think, is nice for us. Although business rules will go in here as well in some sense. Okay, so we have this client class now. I think that's good. I'd like to make it sealed because we have no intention of allowing it to be derived. And if we want it derived, we could just unseal it and then think about how to actually derive it, which could be tricky in some cases. Okay, so now we have a client type. What else do we need? We want to generate this function here. I'm curious to see what return type it generates. Let's see if it's smart enough to use a task. Of course not. So it just returned object, but we'll return a task. So this is our future. So this is a nice little method here. We'll implement this at some point, but for now, let's just return task.complete a task. So this just means that, let me try to type properly. This just means that when you call this function, it's going to complete immediately, synchronously, right? Now, if we go back to this code here, expression type task is not allowed. Oh, right, sorry. It's not just a task. So I should probably point out what this error is just in case you run into it as well. So remember, an observable is an observable of T. It has some data in it. It requires data. It has to know what the type is of that data. If we just return a task, task is like the void future, right? It has no data at all. It's void of data in a sense. A task is the reification of a void asynchronous method. It's like invoking a method for its side effects. There's no data. There's no return value. So then, if we're going to use it here, how would the select many operator know what type you wanted to continue your observable with? Now, I am a little bit annoyed by this because I always thought, well, why not just use unit? That seems sensible, and I've run into this in a few places where it was kind of annoying, and the solution was to then just change it to task of unit. But I always thought, well, why not just make it unit implicitly, right? I mean, you're just mapping void to unit in that sense, and I think that's a reasonable mapping. But I don't think there's an overload for that. Maybe something worth contributing, or maybe there's a reason why it's not there. To be honest, I don't remember trying to implement that myself, actually. Anyway, so the point is that you would definitely need a type here in order for this to work for that select many operation. So what type do we want? Well, we have to have a password that's just represented as a string. Why not? And now we can't use completed task, right? So we'll just say from result, from result, and we'll just pass in null. Oh, we have to tell what type it is. Yeah, there we go. And now we have no more errors from the compiler. Very good. And if we mouse over client, we see it's our client. So now we have a client and we have our password in scope too. Remember, one of the benefits of this syntax is that we have the client scope and the password in scope, and any other stuff we have in scope if we keep adding operators. Although, like I said, this does compile directly to a select many. So in the select many operator, if you called it directly, you still also would have these two both in scope at the same time in the projection. But I digress. So what else do we need to do then? If send the password request a message, right? So if sending fails, terminate the connection immediately. Otherwise, await a password response message, which is essentially what we're doing here, right? We're awaiting the response message, but we're not capturing if the task has an error in it. Well, what happens if the task has an error in it? Because we're allowing the select many to perform the composition for us, we're composing this observable with this task, it's going to also propagate any errors from the task into the output observable as well, I shouldn't say any errors. There's either an error or there's not. If there's a fault or an error, then it will just push or propagate that error to the output observable. Now, what we want to do is if that happens, we want to terminate the connection immediately. So that means a side effect, right? We want to call dispose. So we already did that here as a side effect, which, by the way, well, I'll just add it now. Why not? Oh, I'm not getting any intelligence there. doesn't know what client is. It should know what client is. Sorry, I don't like seeing errors, so I'm implementing. So I'm fixing the error. It's disposable. Okay, and there's our dispose method, which will at the moment do nothing. Right. So in here, what we're doing is we're just disposing of the client as part of the subscription side effect, which we could do here as well. Except the problem is we actually want to use the subscription side effect for an actual valid side effect, right? We only want this to happen if there's an error case. So it turns out that, not surprisingly, perhaps, an observer should be able to observe all three possible cases in an observable: data coming in, which is on next. No more data coming in, meaning that some sort of completion notification, which is called onCompleted, and also an error notification, which you can only have one of. There's either an error or an onCompleted or neither of those, and 0 or more on nexts. Okay, so that's also called the ARCS grammar. And if you look at the ARCS design guidelines document, there's more information about that. That's very important to understand about observables. So the fact that we know we could expect an error through the sort of error channel, and only at most one error, we could just use that to represent our failure to send, and then terminate the connection immediately. So that's one option, right? And if you see the overloads for subscribe, they take in an on next, and then here's one that takes in an on error. So we can just pass in an on error handler here. Now that's one option. There's another option, though, which I think we'll get to in a moment. Let's shelve that for a moment, because I want to continue writing the query so we can see how that would work together. But if your intuition was just to go here and do it, that would probably be okay too. We'll see what happens once we look at the rest of the spec here. Okay, so then we await. So let's ignore this for the moment. We'll get back to it. We're going to await a password response message. If the password does not match, or a password is not received within 2 minutes, there's an arbitrary feature for you. So if the password does not match, so that means we have to do a lookup, right? It also means that we want to have a timeout. So there's really sort of two features in here at the same time. Again, remember, when we're dealing with time, we're dealing with concurrency, and therefore something related to observables would probably make sense, especially if we're dealing with streaming, as we are. So when you hear something like within 2 minutes or 2 minutes, we know that we want some sort of timer. So the question is, how do we do that? Which operator? We know there's going to be an operator, right? Which operator do we want to use to implement this? Well, this is a task, not an observable. So in order to even use any operators on it in the RX world, we're going to have to convert it to an observable. So we might as well just go ahead and do that anyway. You'll notice that it doesn't see this in IntelliSense because we have to add a new using statement, system reactive threading tasks. And then once we do that, you'll see there's overloads. We also have control of the scheduler, which I had mentioned briefly before. And why is there 4 overloads? This one returns a unit. So this is just if it's a, like I said, void task, right? A non-generic task. So the generic task derives from the non-generic task, which is why we have all 4 overloads available to us. But it's going to, if we just call the one with the parameterless overload, it's just going to use this one, the generic one. That's just the way the compiler works. It's going to pick that overload for us, which is important because this one returns a string, which is what we want, whereas the other one returns a unit because it's void, right? Which we don't want. So this is good. We could just call it toObservable, this overload, this overload here, and we'll get back our task of string as an iObservable of string, right? And now that we have an iObservable of string, we want to say that we'll essentially await this observable. Like we could call, you can call subscribe on this observable. We're not calling subscribe. The select many operator will do that for us. But when you call subscribe on the observable, then we want to allow any notification that comes through up until a 2-minute timer fires, right? So this operation is called timeout. And we could set the time span to be from minutes to. Yeah, that looks pretty good. And as a matter of fact, we could even put this on the next line if we want, because Maybe it'll read like the spec a little bit more as well. Also, I mean, just for the sake of indenting, and I mean, just for the sake of readability in general, I guess. So if we start from the beginning, right, from client and whitelisted, that would be like up here when a client connection is received and it's in the whitelist. Then we say from password and client send password request if authentication is enabled, which we know it already is, as a separate if block. Then send a password request message to the client, send password request async. To observable, just a separate utility method we need, but not really technically part of the spec. We'll see a few of those, as we build our queries out. We'll have things like this hanging off of some of our queries on occasion. Do operators, stuff like that. For logging purposes, I meant to say. And then send a password request message to the client. Failing, we skipped for now. Await a password response message, which is really what our from is, right? From password in this. That's awaiting our password response message. If the password does not match, which we didn't look at yet, which we'll do that in a moment, or the password is not received within 2 minutes, that's timeout 2 minutes, right? It reads very much like the spec, top down. Again, the goal. We could say where not is authenticated. How about, we could probably just do another side effect on the client for that, right? Where not client is authentic. Well, I guess it depends on how we're going to be doing authentication, right? Where do we store the passwords and stuff like that? We'll probably just do something like load it from a file and store it in memory for now. We don't have to go crazy with it. So maybe doing it on the client type, maybe it doesn't quite make sense. Maybe we could have we can inject is authenticated as a function in here, just more input into our reactive program. Something like given a client. If you're given a client, then it's like, why not just make it an instance method on the client? Okay, I changed my mind. If you need the client in scope anyway to know if it's authenticated, even if it's just a string, you might as well just have it as an instance method. It's just going to be easier to maintain, I think. So let's go with that. So where not client is authenticated. So when a client is constructed, wherever the password comes from will be available to the client. So that will be part of our object composition, right? We'll have to compose some object graph later that has dependencies for like where authentication comes from, where the passwords come from, or the service for looking that up or whatever. And we'll just have that as part of the client. And again, we want to make our queries read like the spec, that respecting time. This is not a feature that is defined here specifically because it doesn't quite matter. We don't care how it happens. We just care that it happens. It's declarative versus imperative, right? So anyway, so where not client is authenticated, actually in this case we want to say where client is authenticated, right? So timeout, I should point out, I forgot about this. What timeout does is it just calls on error if it quote unquote throws an exception. Throwing in the observable world is just calling on error. So that terminates the sequence. As I said, there could only be one on error, and once there is an on error or an uncompleted, the sequence terminates. I don't know that I mentioned that. It's part of the Arc's grammar. There can't be any more on next after that. So the service, the observable terminates. So on error is a terminating notification. Timeout just uses that notification to raise the error, right? The on error. Yeah. So anyway, so we don't have to worry about reading the data. There's no separate channel of data or something that we have to care about or merge with the password or anything like that. It's just you're going to throw an error or it's not. If it doesn't, then we're going to get our password. If it does, then we're not getting our password. None of this code is going to run, right? So it's just going to call on error separately, which again we haven't dealt with that yet, but we will in a moment. So then we can check where the client is authenticated, and if the password does not match, so that would be sort of the same as a timeout in a sense, right? So if we say where client is authenticated, then we're saying that if it's not authenticated, then just do nothing, which will call on completed. Well, excuse me, it won't call on completed. The reason why it won't call on completed is because we're subscribing to whitelisted, which is a source observable that will not have completed just because this one message was filtered out, right? However, when there's a timeout, it will kill the entire subscription, right? Because it will use on error. Or even if this thing throws an error, as long as it's routed through to the task, then the whole query will be terminated. But with this where clause, it won't terminate the query, right? However, if you look at the spec, if the password does not match, we want to terminate the connection immediately without any response. It's similar to what we wanted to do with the other in the other cases, right? It's almost like we want to just use the on error channel again, but for the specific client. So if we wanted to do that, then instead of where client is authenticated, because this is just going to take a Boolean and do something, what we want to do is we want to just continue the query with another from, where we either return the client or just a unit or some notification that says, yes, continue the query successfully, or throw an error through the on error channel in the observable. So here's how you would do that. You would say from, and then here's where we would do our check, client is authenticated. Technically, I don't think it has to even be a method, right? Why doesn't it like client? Type space client could not be found. That was a little strange, actually. Maybe it's just because is authenticated is not defined on it. I'm surprised that it's not noticing the context anyway, but I just want to see if that's the case. This could probably just be a property, right? Getter. Let me move it up to the top here. Is that better? Oh, it's we have to have a variable for this, right? So I'm just going to use underscore. Underscore in my case is just going to indicate. Sorry, I'm forgetting the syntax for select many actually. So the underscore is just going to indicate that we don't care about the data. It's probably why I forgot to actually write this part, because we just don't care about the data. We just want to continue the query. To continue the query sequentially, we have to use the sequential composition operator, the select many operator, which is again just another consecutive from clause. But because of the fact that it's got to return data, it's an observable, but we don't care what the data is. The underscore is just our way of saying we just don't care about this data. Don't use it, right? So we'll ignore all the underscores in our queries, for example. But now we need to have an observable that we're getting the underscore from. So how do we do that? Well, is authenticated is just going to return a Boolean. So we could just use a conditional operator on that, right? So it's either authenticated or it's not. If the client's authenticated, then we just need a non-error notification, right? So we could just return unit.default. Unit, again, has no useful data. It's just about the notification. Just give us the notification. Underscore will be of type unit, right? And we don't care. It doesn't actually matter to us that it's of type unit because we're not using it anyway. We just want to know that they're authenticated. The reason why we're doing it this way is because of this part of it. We can now say, otherwise, if they're not authenticated, observable throw, and we have to tell it which type the observable is that comes out of the throw. Even though we're only calling on error, it's a generic type. We have to tell it what type it is. And it has to be the same type as the type we're returning on this part of the conditional, the true part, right? Because then underscore can only be one type. In both cases, it's going to be a unit, okay? And then we have to tell it what we're actually throwing. In this case, an exception on a particular schedule we don't care about. Witness we don't need. So we'll just create a new exception. And we'll set the message to be... client is not, or we'll see, let's really just say like incorrect password specified or something like that, right? And maybe just for the sake of clarity here also, I'm just going to format this a little bit. Oh, it's pretty nice. And now if we mouse over client, yeah, everything's good. Compiler's happy. We're getting our client out of this query. So we're either getting our client or we're getting an on error call which says incorrect password specified, or a timeout exception, or any other exception that might occur on the socket level or whatnot when we try to send the password request in the first place. Okay? And in any of the failure cases, if sending fails, terminate connection immediately end. If the timeout occurs or if the passwords do not match, terminate the connection immediately without any response. Right? This is also, I think, saying without any response. Oh, this is if the whitelist, well, that's a different one. If sending fails, to terminate the connection immediately. Send a password request message to the client. So if it can't send the message and it doesn't try to respond, it failed trying to send in the first place. So why would we think it might succeed sending another message? We'll just fail without any response. So in all these cases, we want to fail without any response. Otherwise, if everything's successful, or we just didn't authenticate it in the first place, which is just this vanilla query, right? So here we're doing the query off a whitelist. If authentication is enabled, we're building it back up. I called it Q, but really we don't want it to be Q necessarily. We just want it to be the authenticated client, right? We could even just call it whitelisted. So we could just reuse the whitelist variable. We're just taking the whitelist variable that was defined here, and if authentication is enabled, adding more query goodness to it, and then just using it down here, right? And we no longer have to merge either, because that was wrong to begin with. So we'll just subscribe to it directly, and the side effect is to add the client to the subscription list, which whatever that means, we'll just probably do that in another video. So what are the two things that I wanted to mention? So number one is I wanted to point out, if it's not clear already, that subscriptions are, how should I put this? Well, observables are a model of deferred execution, right? They're lazy. So side effects won't happen regardless of the temperature of the observable, whether it's cold or hot. Side effects won't happen until you call subscribe. If there are any side effects that could happen, they won't happen until you call subscribe. You won't get any notifications pumped through this observable or pushed through this observable until you call subscribe. What this means is we could assign the observable to a local variable and just continue building operations on top of it conditionally. So it's deferred execution. It won't execute until we call subscribe. Very important, right? This is a very important principle here that we get for free based on the way in which Rx was designed. All the operators and the way they're designed, having lazy or deferred execution, allow us to do very dynamic things like this, which is really important in many cases. It's very important here, as you can see. So that was one thing. The second thing was, how are we going to deal with this fault handling now? So these errors, right? These on errors. So let's take a step back for a moment here and just think about this carefully before we proceed, because we have clients coming from this whitelisted observable. If we push an on error through here, or if the query itself pushes an on error, then the whole sequence is terminated, right? The whole observable, the whole subscription is terminated. We're only subscribing once. So if this subscription terminates, right? If we were to put like an error handle here, like this, then we're not going to receive any more clients. The query just goes away. That's clearly not what we want, right? So this approach, although it seems like a reasonable approach, is the wrong approach for us, because we want the query to remain alive. We want to receive additional clients. We might have multiple clients all doing things at the same time. Some might fail for certain reasons, some might not. So we want to handle the ones that fail as individuals, separate from the other clients. So we could do this by examining the query from the point of the source. A client comes in, is pushed into our query at this point, and we're trying immediately, the next thing that we're doing once we receive the client, and for each client, is sending a password request. But this password request might throw an exception. What do we want to do when it throws an exception? Well, according to this spec, we want to terminate the client. And that's it. We don't have to try to do anything else. Just terminate the client. And we already know how we terminate clients. We decided you just call dispose on the client and you're done. You don't have to do anything else. So what we need is some way to say, if this part of the query, let's ignore this part for now, but let's just at the moment just take a look at this part. If this part of the query pushes an on error out, we don't want it to get past this part for this particular client, because if it does, then the whole query is being torn down. So what we could do is we could use, now if this was imperative style code, what would you do? An error is being thrown. How do you stop the error from propagating? Well, you would catch it, right? Not surprisingly, there's an operator called catch in Rx. So typically when you use the catch operator, you're not just specifying the source, but also the kind of exception you might expect. That's important, right? If you're doing something where, if you're dealing with an API that throws specific kinds of exceptions, you should catch specific kinds of exceptions and handle them specifically in the ways that make sense for that type. In our case, we really don't know up front what kinds of exceptions that we could expect from this send password request async, but we do know what kinds of exceptions we could expect from timeout. Timeout's always going to throw a timeout exception. So we could catch a timeout exception specifically if we wanted to. But we don't really have to in this case either, because we know that the result of catching any exception is going to be the same. We're just going to call dispose on the client, right? So we don't have to catch any specific kind of exception here. So if we look at this overload, all we really need to do is pass in an observable, which is the observable to continue with when we catch the error. However, notice that we lose the error itself if we use this overload, right? We won't have the actual exception in scope. If we use this overload, however, we need to specify an exception type. We could specify the base class if we wanted to. And then in the function handler that we pass in, the exception that is caught is passed to us. But we still have to return an observable to continue with. Right, the observable for catch continues the observable. It continues it because, remember, we're not terminating the observable here. That's the point. We don't want to terminate it. So catch operator gives us a chance to continue with more data if we want to. We could continue with an observable that has no data in it, so it just technically just ends right there, which actually is exactly what we want to do. But we could continue with observables that have more data or repeat the query, and there's a whole bunch of other options we could do here, but for now, we just have a very simple problem to solve, which is how do we just call dispose and then go away? Make this sub-observable, right, this sub-query just go away and have the outer query still alive. And that's pretty easy for us to do. So first of all, we need to specify the source of the observable that is the input that we're catching an error on, potentially. And then we have to also specify the type of the exception. And I'm only doing this because we want the exception in scope, right? Because we'll probably want to log it at the very least or do something with it. So now we could take the exception, let's call it EX, and there's two things we want to do here. Now, we could expand this out in a lambda and just, perform the action here, or what we could do is call a method. That would remain more declarative, right? We don't have to care how this happens. We just want to know what needs to be done here. We want it to read like the spec. So reading like the spec is, terminate client. Now, the only problem with this is that notice the catch operator passes in the exception. Let me just get that IntelliSense back for us again. It's not giving it to me, and I'm not sure why. All right, let's just do it this way. Have it your way, Visual Studio. So you'll see the function gives us an exception, but it doesn't give us the client. Why doesn't it give us the client? Because it has no idea what the client is. It's receiving an on-error notification from an observable of string, right? That's what the password return is. It doesn't know what a client is. So it's up to us to create a closure around all the data we need in order to perform this operation. So I'm just going to undo that to get it back to where it was. So yes, we want to call a method called terminate client, but we need to generate the method with some context, with some data. Again, because we're in this query comprehension syntax, we have this client variable, the thing that sort of triggered all this, and there'll be potentially multiple clients with multiple each client having its own subquery. But the client that's currently in scope when this code is running is the client that triggered the send password request async method, which then also failed with an error or a timeout. So we could reference that here. It's in scope. We could just do something like this, terminate client, and pass it to the client. However, remember what catch is. Catch is a function, requires a function passed in that accepts an exception and returns an observable. So terminate client has to return a function that, when given an exception, returns an observable. So for the functional programmers out there, this looks very much like a partial function application, right? It's like this curried form of a partial function. This is actually kind of an interesting problem that I think people run into it and they're just very confused how to solve this problem. And it turns out it's like the bread and butter of functional programming. So I love that about this kind of problem. It's so interesting to me that functional programming solves this problem in such a simple, elegant, and common way. Yet, as object-oriented developers, we kind of fumble around this a little bit and might end up doing some kind of weird stuff here. But what I'm about to do, I would argue, is actually probably the nicest way to do this. And the reason why is, again, we're trying to remain declarative here. Notice there's no lambda here. We don't have to put a lambda here. We'll hide that away somewhere where we don't really want to see it. Here, it just reads like the spec with arguably, maybe a little bit cluttered with this kind of having to specify these generic type arguments, but so be it. This is the static compiled world we live in, so the benefits outweigh the costs for that, I would argue. But anyway, if we read it from top down, we see sending the request, timeout from 2 minutes, although you can see the order here switched a little bit. That's the kind of thing that you'll see happen a lot and when you're writing the queries versus the spec. The spec doesn't depend on order so much because a lot of the time you'll write that you want to do X, Y, or Z, and Z depends on Y, but Y wasn't defined until after, and so because it's English, you can make those kinds of weird logistical mistakes or something. But when you're writing it in the program, especially imperative style, or in this case it's declarative functional style, query style, but it still reads like an imperative style program and actually functions like that in a sense that you can't consume a variable that you haven't defined yet. So we have to have the client first. And then when we call this function, we have to call this function first before we could apply the timeout to it, before we could catch it to do the same action for both of these. So anyway, you end up seeing some reversal in the order sometimes, but I would argue that doesn't make too much of a difference, right? It still reads like the spec, even if we have to change the order of some things. So anyway, so let's implement terminate client and see what happens. So if I generate the method and I go to the definition, it doesn't know what to do. Surprise, surprise. But we know what to do. We need to return a function that takes an exception and returns an observable of some continuation type, which in our case, it has to be the same type as the input, I believe, right? So it has to be a string in this case then. And it takes a client as input. Yeah, there we go. Now, it doesn't like this, though, for some reason. Let me see. Did I do something wrong? Probably. Cannot convert from function exception observable string to function exception observable of client. Oh, because I put client here. My bad. It's a string. There we go. So I just typed the wrong thing. Ooh, and now I don't have to type this. It's inferring it. Oh, look at that. I spoke too soon. There you go. It infers it because obviously it knows how to infer this. We're either passing in an observable or a function of exception to observable. Clearly, it's the second one, so the compiler is able to infer it. Even better. So there you go. This is a way to catch on error without having the outer observable terminate, and also remaining declarative and capturing any state that you might need in order to perform the operation that you need to perform. Right? So what does terminate client actually do? In our case now, we might even cause some side effects here with the logging the exception, right? For example. So, but we have to return a function here. So what we'll do is we'll just return the function like this. We'll say, given an exception goes to, and now we can do whatever we want. Actually, we can even do it like this. And then we have to return an observable of string. What is our observable of string going to be? It's essentially represents a password. So after you catch an error, what password do we return? None. We have an empty observable of string, meaning that it's an observable that has no data at all. It just immediately, when you subscribe, it immediately calls on completed, right? It's an empty observable. So that doesn't mean 1, it means 0 notifications, right? And there you go. Now the compiler's happy, but we also wanted to do some other stuff. So we'd probably want to log the exe, use system diagnostics trace, which we can't because we are in a standard .NET standard library. So again, diagnostics is a cross-cutting concern. We'll implement a nice little generic trace observable or something that we could deal with in the future. So for now, it's going to be something like, trace error ex, something like that, maybe with some message. And then also, we want to dispose of the client. That's pretty important, right? Kill the socket connection. As a matter of fact, we might want to kill the socket connection as soon as possible. Dispose should never throw an exception. That's just a part of the contract of dispose, and the general .NET contract that it's, all of our expectations. So I'm not going to try catch around this. We'll just make sure that we honor that contract when we implement dispose. So it won't throw an exception. If it's going to potentially throw any exceptions, it's going to catch them internally and just log them, because there's nothing really more that it could do with it. Obviously here there's nothing more we could do with it anyway. We would catch it and then just log it anyway. So it won't throw an exception. Then we'll be able to just trace the error after it, and then we'll return an empty string, which indicates that, we're terminating the client but not continuing with any useful information. So going back up to the query, so that's nice. That's one part of it though, or two parts of it. The third part was we're also throwing down here a new exception, incorrect password specified, right? So how do we solve this problem? Well, what we could do is we could just grab this catch, wrap this whole observable in parens, and then put the catch down here. Now, remember, this works because... Oh, sorry, that's not going to work. Because client's no longer in scope at this point. Right. Sorry, my bad. So yeah, so we can't do that because client is not in scope. Again, benefit of this syntax here, right? So then what do? Throwing here, so obviously the intuitive approach would be to just my clipboard's messing up today. I can't copy what I want. That's what I want to do. But anyway, so the point is that you could think, oh, we'll just do something like this. But the problem is that obviously this throw type of unit. If we just made it string, then this would compile, right? Yeah. Still doesn't like this, huh? Oh, I'm missing just a closing parens. Yeah. So there you go. So this would work. I think I have an extra parens there now. Yep. This would work, but the problem is it's duplicating this. That's ugly to me. I don't like the duplication, right? Because even though well, okay. So maybe I'm being a little bit too much of a pain in the ass, because the spec does duplicate it, right? It says if this happens, it's something different, right? If sending a password fails, terminate. Although what's interesting is the timeout and password not matching is one thing, and the request failing is another. But I've sort of changed the grouping, right? Now it's the timeout and the request failing is one catch, and the password being invalid is another. But still, even though the spec does that, like I said, it's English, right? We could rewrite the spec so everything's in completely different order and grouped together in different ways or whatever, and it still has the same underlying meaning, right? The semantics are the same. And likewise, we could do the same with our queries, right? The queries I'm writing aren't necessarily the only way to do this. You might find better ways to do things and simpler ways. As long as it reads like the spec, that's really, or close enough, then that's really the goal, right? But in our case, I could leave it like this, or I could figure out a way to simplify it and have only one, avoid the duplication, have only one catch, so to speak. So how can we do that? Well, the from clause here is actually saying generate another observable, right? But if we wanted to put a catch on this, we'd have to put the catch on a completely separate observable. So the way to do this, in the RxE functional kind of way, is probably not all that elegant though. But let's just do it and see what it looks like. So we'd remove the catches from those locations, and we would need another from, right? Notice the pattern here. From gives us a chance to compose another observable sequentially. Select many, the sequential composition operator, right? We're composing another observable. Then here we're composing another observable. Catch allowed us to drop, put a catch operator or drop an operator on top of another operator, on top of an operator that has some source observable that's being composed. So that's why we're able to put the catch here and keep it within scope, keep it in a place where the original client variable is still in scope, right? If we wrap the entire query and do it outside of that, we lose the scoping. So we just have to follow this pattern. It's just doing the same thing again, right? It's from, now we know that we don't care about what what result we get here, but I'm using 2 underscores because this underscore is already being used. This is actually a valid variable name. So the pattern I use is just keep adding underscores to just indicate other variables in the same query you also want to ignore. It's not totally elegant. I really wish, I think underscore is actually a valid character in like, what was it, pattern matching now, right? I think they allow underscore in C# to truly represent a non-variable, you know, but I don't think it works in query syntax yet. I really wish it would. I think that would be pretty cool, but maybe there's a good reason that it doesn't. Other than complexity, there might be a good reason why it wouldn't be in here. I don't remember. So anyway, for now we're still stuck with just adding multiple underscores to disambiguate between the variable names. It also means you could do weird things, by the way. Like I've seen some people do stuff like this, underscore dot. That drives me nuts because you're doing the exact opposite of what the point of the underscore is, right? If you actually care about this, yeah, I understand you don't want to name things, but if you're going to be that lazy, then just at least use a letter or something. Underscore has very specific semantics, meaning I don't care about this. You should be able to assume that I could freely change this to anything and without even refactoring, and it won't break anything because it shouldn't be referenced anywhere. So anyway, so from double underscore in, and now we need an observable. What do we continue with here? Well, really, we just want to continue with either of the other 2 observables, right? Now, how do we get either of the other 2 observables in scope in this case? Well, the problem is we can't do that, actually, now that I think about it in hindsight, because the catch that we're putting on here, we were putting it on this observable alone. If we create another observable here, we'd have no way to reference these former 2 observables, right? It's just sequential, so they're out of scope at this point. What would we be putting the catch on? We'd be putting it on some other arbitrary observable we created. That's not what we want to do. Instead, what we want to do is create a subquery. In other words, we could project this query. Oops, let me undo that. I just want to format it nicely. Project this query although not, oh yeah, I'm sorry, that's what I messed up. We're going to do a from underscore in this query here, like that, and we'll put another parens around it. Right, so this way we're grouping these 2. Now we can put the catch on the outside of that one. Client is still in scope, of course. We have an extra parens here now? No. It's not an extra parens. From password in this. From underscore. Oh, I forgot to select. That's right. In here we need to select. We could be explicit here and just say select unit.default. Because again, we don't actually care about it. Or string.empty. We've been using strings the whole time because it represents a password. So whatever, that's fine. Yeah. So there you go. I have to admit, it's much easier and more intuitive for me to do this stuff when I'm not talking, right? So if it looks like this is confusing, if I can't do this, then why would you be able to do it? That kind of thing. You hear that from people sometimes. When you're just building this out and you're thinking to yourself, this stuff comes pretty quickly. But when you're trying to explain it in detail and thinking about all the different cases that you might want to raise, it's trickier to notice this stuff. So anyway, this is I think the simplest way to avoid the duplication of the catch operator. Let me just describe again real briefly what is actually happening here. So we're subscribing to, well, we're not subscribing to anything. Let's look at it this way. We're defining a query that says whenever a client is pushed in, a client arrives, then we project that client into a separate subquery that whenever that produces a value, we return the client. Okay, so that's the outer query now. The inner query, or the subquery, says, given the current client, and for each client, we will send the password request, add a timeout operation on it. If they're authenticated, return string.empty because, it's successful, or otherwise throw another exception. and then select string.empty. You know, we don't even care about the password anymore at this point, or technically the password's in scope. We actually could just project the password. Maybe we will want to use it externally. Actually, in that case, this is even the password, right? But we don't have to necessarily name it if we're not going to use it. It probably couldn't hurt though, just to name it as what it is. Oops. Right, and then if there's any failure at all in the subquery, we catch it, terminate the client immediately, and then it's just never projected out. The query never continues after that, and that's it. Right? Having it as a subquery is sometimes clearer than having it in order when you want to do some sort of side effects and stuff. In our case, there aren't really any side effects. There's some side effects hidden in this, but they don't really matter. There aren't any real explicit side effects here. So I would argue that it's actually cleaner when it's not as a nested query. Just having it straight down is a little, I mean, you could see it's a little bit more complicated. You have to think for a moment what's happening here because of the subquery. I find it easier in this case I think it would be easier to understand if it was, you know, not in a subquery. So it's really just a matter of controlling side effects and duplications, right? Do we care about the duplicate or not? In this case, it's the catch operator. But you can imagine in other scenarios, it's more complicated operators, more complicated queries, right? Maybe there's more complicated subqueries that we're duplicating in various parts of the query. So you have options of how you want to deal with it. Allow the duplication or create subqueries that you could provide additional operators on and just compose them sequentially in an outer query, right? So you can see there's a few different ways of dealing with this. And a lot of it's subjective, right? Some of it's going to be like what you prefer. Some of it's going to be like, the spec is written this way, so I'll keep it this way or not. But those decisions are up to you. As long as at the end of the day, you have a 6 or 7 line query in general. You know, there's some wrapping here though. It's just it's an expression. Notice I'm not using subjects, which we haven't actually really discussed those yet. But it's just a single expression, and it reads very much like the spec. That's the goal. Okay. All right. So I think I went on for quite a while in this video, and maybe went on a few tangents. Hopefully they were informative. I think that's probably good enough then for today. Let me see if there's any challenges I could leave you with. I can't move this again. I got to figure out why this is happening. Is it some sort of focus issue? No. I really think it has something to do with this editor. What if I close the editor? Let's see if that makes a difference. Nope. All right. I'm just getting really frustrated by this. I'm just going to... Oh, no. Did I just change something? Let me just undo for a second. No, we're good. Yeah, everything's saved, right? Nothing's changed. Okay. So let me go back to the spec. I can't change this now. You know what I could do though? Move it to the previous tab group. All right, let's do that. And let me see if there's anything that would be interesting to leave you with as a challenge. When a client disconnects, all right, well, it's another when query. It's probably fairly simple, but when a message is received, you're not going to really be able to do much with this because we don't have the subscription list yet. I don't want to leave you with that. I mean, obviously, feel free to look ahead whenever you want. If you want to challenge yourself with anything in the spec, go for it. I would say that if I was going to recommend something, maybe just implement this connection. It's a separate query. You have to figure out how to represent client disconnection, and then, you don't have to actually perform this operation, but it's really just a matter of modeling the input and output, right? Yeah. Oh, the one thing I forgot to do was, well, okay, so I'll just do this in the next video. I wanted to check that the contracts, the input and output, actually made sense for what we wanted now. But I guess, yeah, it would make sense that we actually implement the server first at this point and then see if the contracts actually work for us. So we started with this implementation. In a subsequent video, we'll take a look at the contracts more closely in the business layer and make sure that they actually do match up the way we would expect them to. It's obviously not feature complete yet, but we implemented the bulk of the service at this point, so I think that was pretty good. Okay, yeah, so try this out if you want or not, and I think that's good enough for this video, so thanks for watching.